Now, compared to the lifetime of a star, the creation process of carbon and oxygen is over in the blink of an eye, because in only about 1 million years the supply of helium in the core is used up. And for stars as massive as the Sun, that's where fusion stops, because there isn't enough gravitational energy to compress the core any further and restart fusion. But for massive stars like Betelgeuse, the fusion process can continue. When the helium runs out, gravity takes over again, and the collapse continues. The temperature rises once more, launching stage 3, in which carbon fuses into magnesium, neon, sodium, and aluminium. And so it goes on. Core collapse, followed by the next stage of fusion to create more elements. Each stage hotter and shorter than the last. And eventually, in a final stage that lasts only a couple of days, the heart of the star is transformed into almost pure iron, whose chemical symbol is Fe. This is where the fusion process stops. In its millions of years of life, the star has made all the common elements. The stuff that makes up 99% of the Earth. The core is now a solid ball of those elements, stacked on top of each other in layers. On the outside, there's a shell of hydrogen. Beneath it, a layer of helium. Then carbon and oxygen and all the other elements, all the way down to the very heart of the star. And once that has fused into solid iron, the star has only seconds left to live. When a star runs out of fuel, then it can no longer release energy through fusion reactions. And then there's only one thing that can happen. In about the same amount of time it takes this prism block to crumble, the entire star falls in on itself. This is the destiny that awaits most of the stars in the universe. Yet even the implosion of a star only forges the first 26 elements. What of the remaining elements, some of which are vital for life, and many of which we hold most precious?